Hello, everyone, and welcome to Bookercast, the podcast where books come to life.
And I'm so excited to dive into another amazing story with all of you.
Whether you're a bookworm or just love a good story, this is the place for you.
Every episode, we explore incredible books, talk about their stories and characters, and share insights that'll make you fall in love with reading all over again.
All right, let's not keep you waiting any longer. Get comfortable, and let's jump right into it.
Sounds good.
All right, buckle up, everybody, because today we are diving deep into Michio Kaku's The God Equation.
Ooh, ambitious.
It is, but this isn't just another physics book. It's about the ultimate quest. The theory of everything, like one equation to explain every force in the universe.
The universe's source code.
Exactly. Hidden in plain sight.
You know, what I find really fascinating about Kaku is that he connects this really intense scientific pursuit to something much bigger, like this deep human desire to figure out where we fit in the cosmos. And he starts with this powerful image. Young Kaku sees a picture of Einstein's desk, after he died.
Oh, yeah.
And there's this open notebook right there with his unfinished unified field theory just sitting there. It's like Einstein was, passing the torch.
Yeah.
And Kaku picks it up, driven by that same question, like, what is the universe made of and how does it all work?
And it's easy to think about physics as this, abstract thing.
Yeah.
But Kaku, he's really good at showing how each time we've, cracked the code of a fundamental force, it's changed everything. Society, I mean.
Totally. Newton's laws, bam, Industrial Revolution,
Right.
Maxwell's equations, boom, electric age.
It makes you wonder, right, what a theory of everything could unlock for us.
Right.
What would that world even look like?
It's huge. Kaku really nails that connection, between these big scientific discoveries and how we actually live, how we build the world.
Totally.
And it all begins with, understanding these fundamental forces.
Okay, let's break them down.
So we experience gravity every single day. It keeps our feet on the ground, right?
Right.
But then there's electromagnetism, and that's responsible for everything, from the light we see to the electricity that powers our homes. Wild, right? One force.
Electromagnetism is shaping so much of our world, we don't even see it.
It really is. And then you have these forces operating at a level we can't even see.
The strong and weak nuclear forces. They always sound so intimidating.
They are incredibly powerful. The strong force is what's holding the nucleus of an atom together. Without it, atoms would just fall apart.
Oh, wow.
And the weak force, it's got this crucial role in radioactive decay. Which, it might sound a little scary, but really, that's what powers the core of our planet.
Really?
Yeah. Volcanoes, earthquakes, all that. That's the weak force at work.
So these forces, even the ones we can't see, they're shaping the planet we live on.
They really are.
But Kaku isn't satisfied with just describing them separately, right? He's going for that grand unification, the God equation.
Yeah.
And that's where string theory comes in.
That's it. String theory says, the universe isn't actually made up of these tiny little point particles, tiny billiard balls. It's made of these incredibly tiny vibrating strings. Picture a guitar string.
Okay, yeah.
Different vibrations create different notes.
Right.
So in string theory, those different vibrations, they create different particles. It's a pretty wild concept.
So it's like the universe is this giant cosmic symphony, all these strings vibrating, and that's creating the reality we experience.
It kind of is.
But is string theory, is it really going to be the God equation that physicists have been looking for so long?
Well, it's the leading contender for sure. This fascinating attempt to weave all these forces together into this single elegant equation. But like any grand theory, it's got its challenges.
Oh, yeah. Like what?
Well, let's talk about the Big Bang, for instance. That model, while incredibly successful, has these inherent paradoxes, right?
Like what?
Well, think about this. Why is the universe so flat and so uniform on such a massive scale? That's where the concept of inflation came from.
Inflation?
Yeah, this period of super rapid expansion in the very early universe smoothed things out. Imagine stretching a wrinkled fabric.
So the universe had this crazy growth spurt after it was born. But then does that mean that there could be more than one Big Bang? A bunch of universes just popping into existence.
That's the multiverse idea, coming straight out of string theory.
Oh.
Our universe. Just one bubble in a whole foam of universes.
That's wild.
Each one could have its own set of physical laws, its own story.
Definitely makes you question everything you thought you knew about the universe.
Totally.
And speaking of mind-blowing, we can't forget about black holes. They're like the rock stars of the universe, mysterious, powerful, kind of terrifying.
Oh, totally. Kaku takes us on a wild ride through all those mysteries.
Yeah.
Black holes are these regions of space-time where gravity is so strong that nothing, not even light, can escape.
Yeah, they're crazy.
And they warp the fabric of reality, challenge everything we know about space and time.
And then there's wormholes.
Oh, yeah.
These theoretical tunnels through space-time, they could connect different parts of the universe or even different universes altogether. That sounds like science fiction.
It really does. And Kaku explores all those possibilities. He keeps things grounded in, the physics we know, but he's not afraid of the unknown. Even delves into the possibility of time travel through wormholes.
Okay, but how much of this is just theoretical? Is there any way to actually test string theory? Or is it just beautiful math with no way to prove it?
That's the million-dollar question. Kaku addresses it head-on, talks about the Large Hadron Collider, smashing those particles together at incredible speeds, hoping to find evidence of new particles, the kind that string theory predicts.
I remember that.
But he also gets into other ways to find evidence, like searching for dark matter, studying the very fabric of space-time. It's a big challenge.
Okay, so the search is on. One of the things I appreciate about Kaku, though, is that he makes even the most complex physics, well, understandable.
He's great at that.
It's not like reading some dry textbook.
It's not at all. He's a master of those analogies, real-world examples. It's like you're having a conversation with a brilliant physicist who also happens to be a fantastic storyteller.
He really does bring this sense of wonder to the search for the God equation. But speaking of mysteries, we have to talk about the elephant in the room. Or should I say the darkness in the universe?
The dark universe, yeah. One of the craziest discoveries of modern cosmology, right? Most of the universe is made of stuff we can't even see. Dark matter and dark energy.
It's humbling, right? To think that everything we've ever observed, all the stars and galaxies, is a tiny fraction of what's actually out there.
It really puts things in perspective.
So what are they? Dark matter and dark energy. How do they fit into this puzzle that Kaku's trying to solve?
So dark matter makes up about 27% of the universe. And it interacts with gravity, but it doesn't emit or absorb light.
So how do we even know it's there?
We can see its gravitational pull on galaxies, but we can't actually see it. It's like imagine trying to study a ghost. And then you've got dark energy. That makes up a whopping 68% of the universe.
68%. Wow.
Yeah, and this mysterious energy is actually making the expansion of the universe speed up, pushing galaxies apart faster and faster.
So the universe isn't just expanding, it's expanding faster and faster. Kind of unsettling. What does Kaku say about all this? About the role of dark matter and dark energy in this whole theory of everything business?
Well, he thinks that understanding these weird, mysterious things could be the key to unlocking the secrets of the universe. They're like the missing pieces of a giant jigsaw puzzle.
Okay. I'm starting to see how this all connects.
And string theory actually offers some really interesting ways to try and explain them. Some versions of string theory actually predict the existence of particles that could be dark matter. And those extra dimensions in string theory, they might help explain dark energy too.
So string theory is trying to connect everything, from the smallest subatomic particles to this vast, dark universe. It's like trying to weave a tapestry that encompasses, everything.
That's a great way to put it. But as Kaku emphasizes, string theory, it's still a work in progress. We don't understand everything yet, and the path forward is definitely not clear.
So we're at this really exciting point, right? We have this elegant theory, but we're still trying to connect it to the reality we see.
We are. And that tension between theory and experiment, that's what drives science forward. It's what keeps those physicists searching, asking questions, pushing the boundaries of what we know.
And that's what makes Kaku's book so engaging. He captures that excitement, that thrill of the chase as we try to understand the universe.
But as we go deeper, we hit those big philosophical questions, right? It's not just about the equations. It's about what those equations tell us about reality, about existence, about our place in everything.
Okay, hit me with those big questions. What are the philosophical implications of string theory and of finding a God equation at all?
I mean, if string theory is right, and there's this underlying unity to the universe, well, it raises questions about chance versus determinism.
Whoa.
If everything can be explained by a single equation, does that mean our fate is already decided? Is free will just an illusion?
Heavy stuff. So are we really in control of our destiny?
Right. Kaku tackles these big topics, but he doesn't pretend to know all the answers. He presents the different viewpoints, interpretations, and encourages us to really grapple with them
So it's
ourselves.
not about finding one right answer.
It's about understanding more about ourselves and our place in the universe.
Expanding our understanding.
Exactly.
Which brings us to the core of Kaku's book, right? This quest for meaning in the universe.
Uh-huh.
How do we find meaning in this vast, chaotic cosmos? What's our purpose in all of this?
It's a big question. Kaku looks at it from both sides, scientific and philosophical. He dives into all those attempts to prove or disprove the existence of God and how those arguments have changed with all the new scientific discoveries.
A classic debate. Faith versus reason. Science versus religion. Does Kaku pick a side?
He presents a balanced view, acknowledges the limitations of both science and religion when tackling those ultimate questions. It's about respecting different perspectives and having those open, honest conversations.
I like that he doesn't try to force a specific viewpoint. He gets that these questions are complex and there's no easy answer.
Exactly. And he also has this sense of awe and wonder at the elegance and order of the universe. He points out that the fact that we can even think about a theory of everything, it's a testament to human reason.
It's like we're trying to understand the mind of a cosmic architect.
It is.
It makes you realize that this search for a God equation, it's more than just science. It's a quest for meaning. It's trying to find our place in this grand scheme of things. So where does Kaku leave us in this search? Any conclusions? Any words of wisdom?
He ends the book with this really thought-provoking reflection on what discovering a theory of everything could actually mean for us.
Yeah.
He thinks it could totally revolutionize our understanding of the universe and ourselves, like reaching the summit of Mount Everest. The view from up there would be incredible, but the climb is what really changes you.
It's about the journey, not the destination.
Exactly. And Kaku ends with this feeling of hope and optimism. He really believes that humans, are capable of understanding even the deepest mysteries of the cosmos.
It's inspiring to hear a scientist who hasn't lost that sense of wonder, that childlike curiosity about the universe.
That's what fuels the scientific enterprise.
Well, we've definitely covered a lot of ground in our deep dive into the God equation.
We have.
Explored the four fundamental forces, delved into the world of string theory, even thought about those huge philosophical implications of this quest for a theory of everything. But I feel like we're just getting started.
There's always more to explore.
Right. In the next part of our deep dive, we'll look at some of the more controversial parts of string theory, the challenges it's facing, and even some alternative theories that are popping up in theoretical physics.
Should be interesting.
It will be, and we'll keep wrestling with those big questions,
Yeah.
about reality, the origin of the universe, and trying to find meaning in all of this vastness.
It's a lot to unpack.
Stay tuned, because our journey through the God equation isn't over yet.
Not even close.
All right, so string theory, pretty wild idea, but it's got some hurdles to clear. What are some of the criticisms that Kaku talks about in the book?
Well, the biggest one, honestly, lack of hard proof. Evidence from experiments.
Right. Yeah.
String theory makes these big, bold predictions, extra dimensions, these tiny vibrating strings, but we haven't actually seen any of that.
And we talked about the Large Hadron Collider, trying to find those tiny particles, but, nothing yet. Does that mean string theory's, on its way out?
Not necessarily. It might just mean we need to, get a bit more creative with how we test it.
Okay, yeah.
Kaku talks about how some physicists are looking for these subtle effects, how string theory might be tweaking gravity or light in ways we haven't noticed before.
So it's like trying to find a whisper in a hurricane.
Kind of, yeah. But the payoff could be huge.
Yeah, I get that. Are there other objections to string theory besides just, not finding the evidence yet?
Yeah, there are. One of the main ones is this thing called the landscape problem.
Okay. The landscape problem.
Basically, string theory, as it is now, seems to allow for a ridiculous number of possible universes, each one with its own set of physical laws.
Wait, so instead of one elegant God equation, we get a multiverse of infinite possibilities?
Pretty much.
Doesn't that kind of defeat the whole point of, finding a single unifying theory?
It's like having a map with every single road ever, but no clue which one gets you where you want to go.
Right. So if string theory can fit any universe you can imagine, what's the point of it, really?
Right. Well, some physicists argue that all these possibilities, it's not a bug, it's a feature.
Okay.
Maybe our universe is just one of many, and we happen to live in the one that, allows for life to exist.
So it's like if the universe were any different, we wouldn't be here to think about it. It's a little circular.
It is.
But aside from all this philosophy, are there other ways to actually test string theory besides those tiny black holes and extra dimensions?
There is something Kaku mentions. It's testing Newton's inverse square law of gravity, but over ridiculously small distances.
Right. He talked about how if gravity acts differently at the subatomic level, it could mean those extra dimensions are there, like hidden just beyond what we can see.
It's like looking for cracks in the foundation of physics as we know it.
I bet those experiments are tough to do.
Super tough. We're talking about measuring forces that are unbelievably weak.
It's amazing that they can even try to do that. But even if they find those cracks, wouldn't it just mean there's more to the story? Not necessarily that string theory is, the answer.
True. Science is always evolving.
Right.
Even if string theory ends up being, a dead end, all that exploration will have been worth it.
It's all about the journey, not the destination. But speaking of journeys, if string theory is getting all this pushback, are there any other theories out there competing for that theory of everything title?
There are. Loop quantum gravity is getting some attention.
Loop quantum gravity. What's that?
It's a totally different approach. It focuses on quantizing space-time itself.
Okay.
Picture it as this network of tiny interconnected loops.
So instead of those tiny vibrating strings, we have loops of space-time. Sounds just as crazy as string theory.
It is. It's got its own predictions, its own challenges. It predicts that the speed of light could actually change a tiny bit depending on the energy of the photon.
Wait, so the speed of light might not be constant?
Maybe not. We might be able to see that someday with some really sensitive instruments.
It's amazing how these theories make us rethink things we thought were fundamental laws of the universe. But with all these competing theories, how do physicists even choose which one to focus on? Is it just a matter of taste?
Not really. There are criteria, mathematical elegance, how much experimental support there is, does it explain what we see? Can it predict new things?
So it's like solving a giant puzzle.
Yeah.
And each theory gives you different pieces.
That's a good way to think about it. And the challenge is finding the pieces that fit together the best, the ones that make the most complete picture of the universe.
But even with all the progress we've made in physics, there's still so much we just don't know. It can be kind of overwhelming.
It can. But it's also really exciting. We're living in a time of incredible discovery. We're constantly pushing the boundaries of what we know, questioning everything we thought we understood about the universe.
Which brings us back to Kaku and his message of optimism and wonder. Even if we don't find that one definitive God equation, the search itself is still, it's still amazing.
It is. It's about pushing those boundaries, challenging ourselves, and just, appreciating the mystery of the cosmos.
And remembering that we're a part of something much bigger than ourselves, connected to everything in the universe.
Yeah.
It's a pretty humbling thought.
It really is.
We've covered a lot in this part of our deep dive. Explored the criticisms of string theory, looked at other theories, even thought about how all these abstract ideas could affect us here on Earth.
We have. But there's one really important part of Kaku's book we haven't talked about yet. His own personal thoughts about doing science and about the search for meaning in the universe.
You're right. We need to hear from Kaku himself. He's been a leader in theoretical physics for so long, his perspective is invaluable.
It is. So in the final part of our deep dive, we'll get into Kaku's journey as a scientist, what he thinks about the future of physics, and his message about the power of human curiosity and imagination.
It's about to get personal and philosophical.
It is.
Stay tuned as we try to unravel the mysteries of the God equation. All right, so we've explored all these mind-bending theories, the challenges, the possibilities, but now I'm really curious. What does Kaku himself think about all of this? What's his take on this whole God equation idea?
One thing that really struck me is that even though Kaku's dealing with these incredibly complex, almost abstract concepts, he never loses sight of the human side of science. He talks about his own journey, his inspirations, his doubts. It makes it all feel, more relatable.
Yeah, it's not just equations and theories. It's about real people, driven by curiosity, by passion, by a sense of wonder, even. I love that story he told at the beginning about seeing Einstein's unfinished notes. It's like even the greatest minds are wrestling with these huge questions.
Exactly. And it's not just Einstein either. He talks about all the scientists who came before, their struggles, their triumphs. It's like physics isn't just a bunch of facts. It's this living, breathing thing shaped by human ambition and sometimes, yeah, even by failure.
It reminds you that progress isn't always a straight line. There are detours, dead ends, and then bam, unexpected breakthroughs. It's a process. Speaking of discovery, Kaku talks about the role of beauty in physics. He seems to think that the most profound theories, they often have this mathematical elegance, a kind of symmetry that points to a deeper truth.
He does. He argues that there's this aesthetic appeal to the fundamental laws of nature. It's like that idea we were talking about before, the universe is this grand symphony where everything's connected, harmonious.
Yeah, that's a beautiful thought, but isn't there a danger in, getting too caught up in how beautiful a theory is?
Yeah.
I mean, couldn't it lead you down the wrong path? What if it's elegant, but it doesn't actually match up with reality?
That's a good point. And Kaku acknowledges that. He says beauty alone isn't enough. A theory also has to be testable.
Yeah.
It has to make predictions that you can actually check through experiments to see if they're right or wrong.
So it's a balance. You need that intuition, that sense of wonder that leads you towards elegant theories, but then you need to test them rigorously to make sure they actually hold up.
Right, a dance between intuition and evidence. And I think what makes Kaku's book so interesting is that he doesn't just stick to the science. He goes for those big philosophical questions too, about God, the meaning of life, our place in the cosmos.
Absolutely. And I love that he doesn't shy away from them, even though they're, beyond what science can traditionally answer. He doesn't pretend to have all the answers, but he explores the different perspectives, and he does it with respect, with humility.
He even talks about his own thoughts on those questions, the awe he feels when he thinks about how vast and complex the universe is, how it makes him feel humbled.
It's like he's saying, even if we find that God equation, that ultimate theory, there will always be mysteries we can't grasp. Questions that push us to the very edge of what we can understand.
Right, and that's the beauty of science, isn't it? It's not about having all the answers, it's about the exploration, the constant search for knowledge, the willingness to face the unknown.
I totally agree. Pushing those boundaries, challenging what we think we know, and just being amazed by the universe.
And as we wrap up our deep dive into the God equation, I think that's the message Kaku leaves us with. The search for knowledge is always worth it, even if we never reach the final destination. It's about broadening our horizons, questioning our assumptions, and embracing the mystery and wonder of the cosmos.
It's about realizing we're part of something so much bigger than ourselves, connected to this vast universe. And that's a pretty profound and humbling thought.
It is.
I think that's a perfect place to end. To all our listeners, thank you for joining us on this incredible journey through the God equation. We hope you enjoyed exploring these amazing ideas and wrestling with those big philosophical questions. Keep looking up, keep asking those questions, and keep searching for the truths that connect us all.
And that's a wrap for today's episode of Bookercast. We hope you enjoyed diving into it as much as we did. Thank you so much for spending your time with us. Your support means the world, and we can't wait to hear your thoughts on this episode.
Don't forget to subscribe, hit that like button, and share this episode with your fellow book lovers. And let us know your thoughts in the comments below. We love hearing from you. See you in the next deep dive. Bye for now, and happy reading.